Let's look at ways or method of preventing steel rusting. Basically there are two methods: the cathodic protection using an inert anode, and the sacrificial protection using a reactive anode. If you look at this question closely, without this information given here, this one is a cathodic protection because of the power supply or the battery, and it has an inert anode. This is not sacrificial anode protection, right? Because there is the anode here is not reactive. Titanium is very resistant to corrosion, so it does not get used up in the process. Now, before I get in detail about the explanation, giving the answers to this question, this is a past IGCSE question. So relate to ways of preventing steel rusting or corrosion. This is the anode. It's made of titanium. It's very resistant to corrosion. And this is the cathode, the steel oil rig, which is cathode. And you have the battery or power supply. Seawater contains, this is the electrolyte. Seawater contains hydrogen ion, sodium ion, hydroxide ion, chloride ion in in the solution, right, in the aqueous state. So we have the anode, we have the cathode, we have the power supply, and we have the electrolyte. So this is more of an electrolysis process. Electrolysis process. It is not an electrochemical cell, right? So this electrolysis process is going to take place here. Now, the first question, define oxidation in terms of electron transfer. Electron transfer. So, in terms of electron transfer, so I will just say, I will write electron loss, right? Electron loss is oxidation. Then the second question, the steel oil rig is the cathode. Name the gas formed at this electrode. To name the gas formed at this electrode, name the gas formed at this electrode. That is the word referring to the cathode. So to know the gas does not typically come out. It comes out from the electrolyte here, right? So there is no gas, titanium not here. It's from the electrolyte. Now, if you look at the electrolyte, these are the ions, right? These ions are mobile. They move randomly. But when the circuit is closed, they now align themselves to the electrode of opposite charge. So these positive charge ions, known as cations, they are attracted or they migrate both to the cathode. Right? These are cations. They migrate to the cathode or to the negative electrode. Now here, hydrogen ion and sodium ion, when both get there, one of them will be discharged. One of them will be discharged, and to know which of them will be discharged, it depends greatly on their position. The position of these ions in the electrochemical series. Electrochemical series, right? Now, the one to be discharged is the one that is lower in the series. So look at the electrochemical series where selective discharge of ions take place. If you look at this is selective discharge of ions. These are the ions, the cations, right? Now my question is revolving around, is it sodium ion or hydrogen ion? This is hydrogen ion and this is sodium ion, right? Sodium ion is higher up in the series. It's more electropositive than hydrogen ion. the discharge depends on the position. The one that is lower in the series will be discharged with preference to the one that is what on top in the series. So hydrogen ion will be discharged with preference to what sodium ion. If you had zinc and what calcium, it will be what zinc, because zinc is lower. Hydrogen is less electropositive, this is more electropositive. The less electropositive one or the less reactive one are discharged to what the more reactive one or the more electropositive what ions in the series. These are cations. So hydrogen will be discharged. Hydrogen will be what discharged. So how do you do that? This is a cathode, right? And you have here hydrogen. This is hydrogen. Hydrogen will remove electrons from the what cathode. This hydrogen will accept 2 electrons, and that's the hydrogen gas. So that's how it is formed. The hydrogen ions in the electrolyte gains or receive 2 electrons from where? The cathode. The cathode. And it is now discharged as what hydrogen gas, right? Now what you have here is what hydrogen. Hydrogen, that's the name of the gas form. And the cathode, you see bubbles at the base around here, bubbles, right? Bubbles of what? Odorless, colorless gas. Now the next question is number 3. Name the 2 gases formed at the what? Titanium what? Anode. These also will be attracted by the word anode. Anode is the positive what? Electrode, right? These are negative ions known as what? Anions. These are anions. A for A. Anions go to the what? Anode. Cations. Cations migrate to the what? Cathode. So these 2 anions will be attracted by the word anode, the positive word electrode. So it's a name 2 gases. A hydroxide ion will be discharged as what? Oxygen. And this will be discharged as what? Chlorine gas. So let's look at how actually hydroxide ion getting to the word anode is discharged as oxygen. It's an equation to represent that. If you have what? The anode, hydroxide ion will release 4 electrons. So release 4 electrons, donate 4 electrons to the what? Anode, right? So the bubbles you find around here, bubbles we find around here at the base of the what? This is the anode, the base of the titanium what? Anode. And the electrons will now move up, right? Pushed by the battery, right? So this is the gas, how it is what? Formed. This is oxygen what? Gas. So one of the gas is what? Oxygen. Right? The other one, of course, is what? The chloride ion will also be discharged as what? Chlorine. It will lose 2 electrons, and that is the gas. This is the first one, this is the second one. So you're going to have what? Chlorine gas. Also form at the what? Anode. At the what? Anode. Now, if you look at the last question, well, I got this. I jumped a lot of steps. Actually, you can form this by looking at you have hydroxide ion giving out the first electron, and you have OH, right? This will also give 1 electron. You have OH. When you pair them up, you have 2 OH minus. You have what? Minus 2E. Then this will form water, H2O and oxygen. So this will also pair up two electrons, they have H2O plus O. When you add these two, you're going to have 4OH, right? Minus 2 plus minus 2 is minus 4 electrons. Then you have 1, that's 2 moles of water, and what? Atom plus atom equal to what? A molecule, right? So that's how I actually got it. What they need, this is just this. This is just to achieve this. And that's how I got this equation, right? To present how oxygen is what formed at the anode. Now the last, but not the least question, that's number 4. Explain why the oil rig does not what? Rust. Oil rig does not rust. So you can simply write that the oil rig cannot rust. Oil rig does not rust because, right, electrons are received from the battery, right? Oil does not rust because electrons are received from the battery. That is what? Reduction, right? That is what reduction. We all know that rusting is oxidation. Electron must be lost from what? Iron or steel for rusting to take place, not electron received or gained by iron or steel. That's reduction. For rusting to take place, iron must be oxidized by losing what? Electron. So that is the answer. Oil does not rust because electrons are received from the battery. That is what? Reduction, and not what? Oxidation. So this is how you answer questions as it relates to what? Ways of preventing what? Steel from what? Rusting or corrosion. This question is really anchored on what? The sacrificial, it's anchored on the cathodic word protection using an inert word electrode. That's the word platinum word anode, and with either the power word supply, the battery. The platinum is not what used up at the end of the day. This is an expensive process, but it's mainly used as an industrial word process to protect what? Large what? Steel structure. I hope this is clear. I wish you all the best. This is one of the IGCSE past questions that relate to what? Cathodic protection using an inert word electrode.